let's say that we wanted to write a program to accept a list of grades and compute the average of those grades. Okay, so that's the idea. So what we have here is at least the beginnings of a program that could do that, the break with loops. It looks like it's kind of allowing us to enter some positive numbers and then creating a sum of those numbers. So that's sort of like what we want to do. So maybe we can work with this. Why don't we create a new program and we'll just copy this stuff. Okay. I'm going to copy that into a new program. Maybe we can just massage this a little bit and get something. Okay. So we're going to call this program list headed by size. So what we're going to try to do is read in a list of grades. And it's going to work like this. All right, so we're going to say enter number of grades. Okay, and so for example, maybe we'll enter like 3. Okay, then we're going to say enter grade, and we'll just enter a grade. Like here's 90 for this student, yay for that student. Enter grade. 80 for this student. Enter grade. And maybe 85 for this student. And then after we've entered that information, the computer will compute the average, and say that the average is 85.0. Okay? And then the program ends. So that's the sample, I would call this like sample input / output. Okay. So it's just computing the average of a bunch of grades. Okay, cool. So we want that program, this list headed by size program, to work. Now, I see one thing I've been forgetting to do, which I would like to do up here, and that is I want to just make sure that we have my name. Let's see. Let's see if we can find, here we go. I'm sure I did it here. I was getting a little lax in doing that, so let's make sure I get that information. Okay, cool. And maybe I'll put that import. I just want to move things around, make things nice and tidy. It's like cleaning your room. Okay, cool. I'm happy with the way that's set up now. All right, so that's what I'd like the program to do. And I think I can sort of cannibalize the work that we just did. I think we're going to have a sum in order for this to work. Once we know how many grades we want, we're going to sum up 90 plus 80 plus 85. And this code right here, this for loop is pretty sweet. It's kind of doing what I want. The problem is that it's summing up 5 grades. I only want to sum up 3. But actually, I want to sum up however many grades the user tells me. So maybe what I can do here is right here, I can say system.out.println, and I'm just going to copy my sample output, enter number of grades. Maybe I'll make it a print. And then I'm going to say int what do I want to call it? Size. That's the size or the number of grades is equal to input.nextInt. All right. I'm using a little cutting and pasting so I don't mistype stuff. Good for me. All right. Then we have an accumulator variable and a for loop. Now the for loop here, an accumulator variable is sum. That's going to hold all the grades as they get added. The user enters them. So we're going to say for int I equals 0, I is less than 3. I don't want it to be less than 3. I want it to be less than the number of grades that the user gave me. I don't know, size? Yeah, okay, we'll use size. So size represents the number of grades, the size of the list of grades. So I'm just going to put size here. So now the for loop will run from 0 up to 1 just shy of size, which means it will run size times. So however many number of grades the user tells me here, this for loop is going to run this block here that many times. Okay, instead of entering positive number, we're going to say enter grade. And then we're going to get the grade. Now here I'm assuming the grade is a whole number. So I don't want to call it number though. I'm going to call it grade. Now I could call it number. It would just work just fine. But the thing is, the closer the variables that you use in your program align with the code that you're writing and your ideas, the clearer your code will be. All right. I don't want to have this stuff. That'll just complicate things. But it was cool, and it will definitely be useful for you. But in this program, we're going to try and keep it simple. All right, enter grade. All right, so we get the grade, and then sum equals sum plus, oops, not number, but grade. Sum equals sum plus grade. All right, so every grade is going to get added sum, and it's going to be we're going to add size number of grades, and the user tells us in advance how many grades we are going to expect, and then the user is going to enter all those grades. We're going to add them to sum, and finally sum will have the sum of all the grades. Okay, the sum of the grades is sum, but we wanted to print out the average. The average of the grades is, what is the average of the grade? The grades. Well, let's think about this. In order to get the average, we need the total number of grades all added together. That's sum. And we want to do what? We want to divide it by the size, right? So sum divided by size. All right, let's try running this. Enter number of grades. Well, our demo was 3, so 3. All right, first grade is 90. Second grade is 80. And the third grade is 85. Okay, the sum of the grades is 255, and the average number of the average of the grades is 85. Cool, pretty sweet. Now, the one thing I would say here is, in my example, I said the average is 85.0. So as a student, I would like my grade to be not rounded down to the nearest whole number. I would like it to include the decimal information. And so how do we do that? Well, this calculation here involves sum, which is an int, and grade and size, which is also an int. So maybe I can force sum to be a double. Okay, so I'm going to upcast sum to be a double here. All right, now if I do this expression, double sum goes from 255 to 255.0. If we divide it by size, we're in good shape. We're going to get a double. So let's run it. 3 grades, 90, 80, 85. Okay, perfect. The average of the grades is 85.0. Now we're getting a decimal point. That's lovely. All right, so that's an example of a technique that is very common in loops, where you ask the user for some input, but you don't specify in your program exactly how many things you're going to get from the user. So that the input from the user is effectively a list. That's why this is called list headed by size. So we're getting a list of data, and we don't know in advance how big the list is, so we need the user to tell us. So we say, hey user, how many things are in the list? Enter a number of grades. Okay, now enter the things in the list, blah, 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 blah. We do some processing of that, and we end up with a result. So that's a very common pattern of using loops. But let's take a look at another pattern, all right? So this pattern is slightly different, and it has a slightly different name, but it achieves kind of the same goal. So we're going to do a file, new file, and we're going to call this list list with sentinel value.java. or we don't have to say Sentinel that. We can just call it list with Sentinel.java. Sentinel. Okay. So list with Sentinel. Okay. So let's take a look at the sample input output. This is going to look a little bit different. In this example, what we're going to do is we're going to just prompt the user to enter the grade 90, enter grade 80, enter grade 85. So we don't ask the user in advance how big the list is. That's cool. But the question is, how do we know when we're done with the list, done with the list of data? The way we do that is we enter something called a Sentinel value. Okay, so we provide some value, some grade that's so ridiculous it could not possibly be a valid grade. And when we see that value, we know there's no more data to process. So that's what a Sentinel value is. So I'm going to say -1. So if the user enters -1, that's an impossible grade. It would be a very, very mean grade for a professor to give to a student. And then we know that there's no more data to process, and we can print out the average. All right, so to get that to work, what we're going to do is, well, let's see. There's a lot of similarities here, so let's see if I can grab some stuff. I'm still going to need, I don't need the size because the Sentinel value will handle it for me. But definitely, well, I don't need a size the way it's set up here, but let's grab the sum. Okay, we definitely need our sum. So I'll bring that, put that here, and we're definitely going to need to get the grade, and we're going to need to add sum to the grade. So we'll put that here. I'm not sure exactly, there's still a loop in here somewhere. Not quite sure where that goes yet. So, but at least having this stuff in place will be helpful. I can work with it. I can indent it or whatever. And let's get back to here. And we're definitely going to print out the sum of the grades as sum and the average of the grades as well. So we'll put that down here. So we're kind of sketching it out. We're taking advantage of work we already did, which is great. I call that eating your own dog food. It's kind of an interesting expression, but if you work at a dog food factory and you have a dog at home, you should be giving the dog food that you make at your factory. You shouldn't be going out to the store and buying some other company's dog food. You should be really proud of the work that you're doing. So we worked hard to come up with a list headed by size, so why not take advantage of some of the code that's there? Now this code isn't going to work just quite right just yet, but it's headed in the right direction. So I know that this part here is going to be in a loop. All right, it can't be in a for loop because for loops know exactly how many times they're going to execute. We don't know that. We just know that when we get this enter grade -1, we're gonna be done. So here's what we're gonna do. I'm gonna make this a do while loop. And while grade, well, it's something. There's something that's gonna stop this from executing. So we got to think about that. So we want to stop executing this loop when grade is bogus. All right. In other words, when we have the Sentinel value. So we could even right up here, we could do a final int Sentinel and set the Sentinel value equal to -1. Okay. All right. So now this, we really want this do while loop to run as long as grade is not equal to Sentinel, right? As long as grade is not equal to Sentinel, we want this loop to keep running. Okay, I'm liking this. I think we got something here. Okay, the only problem is we don't have a size. So in order to compute the average number of the average for the grades, we need to take the sum of the grades that have been entered by the user, and divide it by size. Well, I think it makes sense inside this do while then to do something to help us keep track of size. So let's create size variable and set it equal to 0. And this is going to be number of grades entered so far. Okay. All right. So initially we have 0 grades entered so far. then when you have a grade that gets entered, we're just going to add 1 to size. There we go. We entered a grade, add 1 to size. And also add the grade to sum. All right, cool. Now I think we have something that's going to work. It's still not quite perfect yet, but let's explore it a little bit and see what happens. It's good to just keep writing a little bit of code and then running it and testing it. Well, okay, we got a little problem there with grade. Let's just get rid of some of these things. Okay. It's saying it can't find grade in here. Oh, that's because grade is declared in the code block of the do while, but when we get out of the do while and do this check, grade doesn't exist. So it exists in this code block, but outside the code block when we're doing this Boolean expression, it doesn't exist. So we're just going to grab the definition of grade and put it up here. And there. Now we should be good. We've declared it outside that do while. Okay. So enter grade, awesome. So we had 90, 80, hey, this is great. 85, awesome. -1, oh, the -1 worked. The sum of the grades is 254, and the average of the grades is 63.5. That doesn't really match what we did up here, enter number of grades 3, when we were doing list headed by size. This looks correct. This does not look correct. So do you think you know what happened here? There's a little bit of a clue here. Look, the sum of the grades is 255. The sum of the grades is 254. And why is this grade so low and the average so low? That's not right. Well, take a second to think about this. Some of you might know and some of you might not be sure, but you might want to hit pause for a second to think about it. Okay, if you're back with me, here is what is kind of curious, right? If we add up these numbers, 90 plus 80 plus 85, we get 255. And then if we subtract 1 from that, we get 254. So maybe what's happening is the sum of grades is adding the -1, our sentinel value, to the sum of the grades. All right, so let's take a look. Whoops. Let's go over here. That looks like what's happening here on line 29. If we say enter grade, and if the user enters the sentinel value of -1, we increment the size. So instead of having the 3 grades, which we should have, size goes to 4, which we don't want to do. And then we take sum and add -1 to it. So that ends up subtracting 1 from sum. We really don't want to do that. We only want to do we only want to do this when grade is not equal to the sentinel value. So we could write that if grade is not equal to sentinel, then we'll do this code. Okay, cool. So basically, if the grade isn't sentinel, we're going to add 1 to size and add the grade. If it is sentinel, we won't do that and we'll kick out. All right, so let's compile and run that. Enter grade, 90, 80, 85, -1. Much better. Sum of the grades is 255 and the average of the grades is 85. So it's not counting -1 as a grade anymore. Now, can we improve it? I mean, take a look at this code. It does look a little bit repetitive, right? We're checking to see if grade is not equal to sentinel, and then we're saying, well, grade is not equal to sentinel. It seems like it's kind of repetitive. Is there a way to make the code a little cleaner? Well, yeah, there is. We can just do a little bit of modification here. What if we do this? While true. That's crazy. Oops, while true. And get rid of the do while. All right, so basically now this runs forever. but we want to stop running when grade is equal to Sentinel. So if we do this, if grade is equal to Sentinel, then break. Otherwise, what we'll do is we'll add one to size, and that looks a little cleaner to me. I don't know what you think. Maybe that while true is freaking you out a little bit, but you can do that. You just say run forever until grade is equal to Sentinel, and then we break. That's not so bad. That actually, I think that looks cleaner than the previous solution. All right, let's test it. Enter grade 80, 90, 85, -1. Perfect. So it still works. All right, that's a nice clean solution to the problem. Okay, so that's another way that we can read in a list of data. And in this case, we don't know how much data there is. We just keep reading on data and data and data, keep reading in until the user gives us a Sentinel value. And in that case, we stop reading it in and we compute we print out the sum of the grades and compute the average. All right, cool. There's one other technique that I want to show you, and I would call it the somewhat needy technique. The program runs, but it needs to know for every piece of data if there is more data to be input. So I'll show you how that works. So we'll do a file new again. And this is called list ask before iterating. Okay. And we're just going to copy all the code here, and we'll just modify it so that it works for this. So the way this works is you allow the user to enter a grade like 90, and then you immediately say more input 0 equals no, 1 equals yes. And then the user will enter 1. And then you say enter grade. And then we just repeat this. Oh, so more input, question mark. Okay. All right, and then we'll run it again here. More input. After the user enters 80, we'll say more input, 0 equals no, 1 equals yes. More input. After the user enters 85, more input, 0 equals no, 1 equals yes. Well, the final thing will be 0, and then we will compute the average. So this is a little bit like the Sentinel value, except in this case, what we're doing is we're asking in a separate query, is there more input? All right, so we allow the user to enter a grade, and then we say, is there more input? 0 equals no, 1 equals yes. It does look a little bit like that list with Sentinel, but there's a catch. Sometimes when you're getting input from the user, you can't pick a Sentinel value. Like, what if it was possible with Sentinel to have a negative grade and have that be meaningful? That's certainly a situation that can happen, right? If you're reading in data and you're reading in either integers or doubles from the user, it may be that any value for an integer or double is considered valid, in which case you really can't pick a Sentinel value because the Sentinel value might actually be real data. So the solution when you're in that situation is to do ask before iterating. So basically you treat the data that's input and the question about whether there's more input or not as separate things. It's more obnoxious and it's certainly more tedious to work with, but you can get it to work. All right, so this is the sample input and output that we want for the program. So let's change this to list ask before iterating. And I don't need this Sentinel. I'm guessing that this while true would be useful as well. Enter, we're gonna do, I don't know, we'll see if we can continue to take advantage of the work that lists with Sentinel did, but maybe modify it a little bit. So system out println enter grade, so the grade gets entered. And then let's compute, there's always gonna be a valid grade. So let's compute that. add one to size at some grade, but then we have to ask the user, is there more input? So let's do that. Sysmap print line. Instead of enter grade, we're going to say more input. Whoops, more input. 0 equals no, 1 equals yes. Okay, now I guess if we're going to leave that if grade equals sentinel, we could probably modify that a little bit. So we'll get more equals input dot next int. Okay. All right. And if more is equal to 0, meaning there's no more input, then we're going to break. And all we have to do here is we just need to, I guess we can declare more right here. Int more equals, yeah, why not? We don't need to declare it out there. Okay, so let's take a look at this. We're going to get the grade from the user, and no matter what, the grade's always going to be valid. So we'll increase size and increase sum. Then we're going to prompt the user with a, hey, do you have some more input for me? And if the user enters 0, we're going to break. So this while true is going to run forever until the user enters 0. All right, let's try running it. Enter grade, 80. Well, let's do 90. 90. More input? Yes. Enter grade, 80. More input? Yes. Enter grade, 85. More input? No, I don't have any more input. 0. Some of the grades is 255, and the average of the grades is 85. Perfect. All right. So the distinction between this and the sentinel is that since we broke up the answering the question about whether we have more input, we took that out of the possible values of grades that could be entered by the user. We opened it up so that any grade, positive or negative, could be entered by the user. And that means that we don't have to worry about a sentinel value. So in some situations, like probably this grade example, a sentinel value would be perfectly acceptable, but in other situations, it won't be. The ask before iterating technique allows you to make that separation, and you don't have to know in advance how much data there is. The user can just keep entering data until there isn't any more data. Now, I think I want to clean this up a little bit. I do use while true occasionally, especially if it can make the code a little clearer. But I feel like this if more equals 0 and the break, it really is like a, I don't know, it feels like it should be more like a do while. Like it just feels like it would be cleaner if I just said do while more is equal to 0. All right. That feels like it would be much cleaner. The only issue with doing that, right? I just cut down the code. It looks pretty short and sweet, and it's pretty clear. The only issue here is I don't like that int. I think I want to get rid of that because more is declared inside the do while block, but then it's tested outside the do while block of code. So I'm going to declare more up here and get rid of the declaration there and just compile and run. We should be good. Oops, forgot to put a semicolon there. Enter grade, 90. Yes, there's more input. Oops. Looks like I have a little error here. While more is equal to 0, while more is not equal to 0. Enter grade, 80, 90, 85, and no more grades. Perfect. Okay, so it's just a cleaned up version of ask before iterating using do while. All right, well, I hope this was helpful. We now have 3 different ways of thinking about handling lists of data that we might process. So we have option 1, which is lists headed by size, where you tell the program in advance how many grades should you expect? So we're reading that in, and then we set up a for loop that processes based on how many grades we're expecting. Now, the program's flexible because every time you run it, you can tell the program, hey, I'm expecting a different number of grades. All right, then we have another technique which doesn't rely on knowing the number of grades in advance. This is list with sentinel value. So here we're entering the grades 80, 90, 85, and then we enter a ridiculous value for a grade. That's called the sentinel value, and then compute the average based on the first three values. And finally, we have ask before iterating. This doesn't require you to specify the list headed by size, and it doesn't require you to enter a bogus grade. So it opens things up so that any value could be a valid value for a grade. And it does that by separating the question about more input from the actual grade entry. So they become two separate questions. But it's a lot, it takes a lot more typing or interaction to work with. All right, well, I hope you found that really helpful, and we'll be getting on to, we've done a pretty good job exploring the basics of repetition now, a really good job. There's a lot to process here, but I think what would be effective next is to take a shot at writing a few more complex programs. So stay tuned for that coming up next.